All right, hello. We're Team 15, and this is our project. Our system is titled Smart Mart. I'm Jaden Benson.
I'm Trey John Bell.
I'm
I'm
Tasha
nine.
Gaither.
Hey, running back.
What the heck, bro?
First
All
of all,
right, cool, cool,
I
cool.
wasn't even mute, so it's probably gonna like be echoing anyway. Oh,
All
sorry.
right. We're Team 15, and this is our project, our senior design project. Our system is titled Smart Mart. My name is Jaden Benson.
My name is Trey John Bell.
My name is Tasha Gaither.
My name is Naeem Harris.
I'm Carson Sisk.
I'm EJ Young.
Okay, so after the COVID-19 pandemic, there was a huge problem, a huge issue with the global supply chain. Um, and there's currently a growth in the use of RFID technology, and this growth has been triggered by a number of issues such as shortage of drivers for delivering supplies, logistics provider capacity issues, inflation delays, cost increases, etc. RFID technology is so beneficial. It's, it's considered a huge solution for this crisis, as this technology provides ways to not only track and manage products, but also create a predictable system in supply chain. And our objective or goal was to design a POS system within the 3 month span of the semester that was cost effective, with a cost less than $500, that will use this RFID technology to manage inventory as well as manage accounts of our customers. So this is a brief overview of our project. In the back, we have a cork board which has 12 different hooks, which holds 12 different items, which is your common goods that you would get at a generic supermarket. Um, here is a here is our Raspberry Pi tablet or screen that displays like the process of our system, and it's sitting on top of a 3D printed base. It houses a printer, RFID scanner, which is shown, a barcode scanner, which allows customers to scan coupons. Um, and as I mentioned before, these are basic household items. You see, you have cheese, bananas, Skittles, eggs, etc. And here is our coupon catalog that allows customers to get discounts on their items. The base that we printed, the black box, essentially is a 10 by 10 inch 3D printed box, and it was designed using SolidWorks. And the drawing contains two extrusion cuts, one which houses the Adafruit thermal printer, and that cut is 46 millimeters by 85 millimeters, and it has a depth of 2.5 inches. And it allows for the power supply and the TX and RX wires to connect directly to the Raspberry Pi. And the second extrusion houses the RFID scanner, and that cut is 60 millimeters by 39 millimeters, and it has a depth of 1.5 inches. And the RFID scanner is connected to the Raspberry Pi using female to female wires, and it's held down by two standoffs. And the base also has an extrusion in the back with a diameter of 4 inches that connects it to the power supply. You muted, Trey.
Here's a pinout for RFID. I'll talk about more in the connectivity that we have in a later slide, but you have your standard ground, your voltage. We don't use pin 4 or 8, but you have your MISO, MOSO, which is master in, slave out, master out, slave in, and your serial clock. Thanks. All right, so RFID flowchart. So this is how you will add your users and your items in your catalog and in your database. So you will take a blank card or a blank tag card will respond to a wallet or a user or a customer, and your tag will be your item, your store inventory. Whenever you have an unknown tag, you'll scan that and that'll go into the catalog database. And then you can add in inventory. You can add in as much as you want, and then it'll terminate the program. As well as you can add in users or customers with your cards. You scan those that are unknown, and it'll add that into your accounts table. And this is what makes up the POS system. And then once you scan the tag that's already known, then it should pop up as identification on the screen. Next. So this is the circuit diagram that shows you a easily understood pinout of how is connected the RFID and the Raspberry Pi are connected. So your GPIO is general purpose input output. So most of the pins have a direct connection, your voltage, your ground, your GPIO, MISO, MOSO, but we use GPIO general GPIO pins for your reset. That's and your serial. But for the others, they have their own direct pinouts. Next. So the technology that Jaden kind of talked about how it solved the industry problems is because of how the RFID is built. So it has a tiny radio transponder that will take in information and read it and also send it out. So it operates on 13.56 megahertz. That corresponds to 1 to 3 feet. So it solves these problems because it eliminates the site of scan that you have with a barcode or insert card reader. It allows you to process a tap and go. So whenever you are within that 1 to 3 feet, the RFID reader will pick up the identification of the tag or the card and automatically read that in and process it through that account or that catalog table that I discussed earlier. Next. So this is the thermal printer. It was made by Adafruit. This is kind of a pinout of it. So we had a Amazon 9-volt battery external that was wired to the battery, and then your RX and your TX are your receive and your transmit pins. But the printer is 2.25 wide. That is how wide the extrusion is in the overall enclosure. Like I said, the 9V battery is how it's powered. And the TX and the RX are connected inversely so that whenever you have information that the Raspberry Pi wants to transmit, it's received by the thermal printer. And whenever you have information that is transmitted through the thermal printer, it's received by the Raspberry Pi. And the first bullet points just kind of tell you how those pinouts kind of establish that serial interaction. Next.
The thermal printer operates without the use of ink or toner. It accomplishes this by applying heat and pressure to the special thermal paper, creating a blackening effect. The printed head is the mechanism that controls the heating element that corresponds to the printing resolution. The special thermal printer paper has 4 layers: top coat, substrate, adhesive, and liner. Here's a picture of barcode scanner on its stand. Here's the flowchart showing how the barcode scanner scans barcodes. First, a table in SQLite 3 was made, containing all of the barcodes we have registered. Secondly, we created the corresponding barcode labels in Excel. Then we were able to use the barcode scanner to scan our newly made barcode. When a barcode is scanned, the barcode is checked to see if it is in the database. If it is in the database, it displays that information on the GUI. If it is not, nothing is displayed, and we're waiting for the user to input.
So here you can see our computation methodology. We decided to build our backend using SQL instead of Excel. Using SQL allowed us to integrate the backend tables into our front-end code more seamlessly. We use the SQL commands such as select, insert from all of these could serve as a VLOOKUP to find specific data and help us manipulate our data. Using SSH, we could get into the Raspberry Pi with this IP address. The app that we use allowed us to manipulate our GPIO pins. We could communicate with our Raspberry Pi and turn things like LEDs on and off. The limitation with our app is that we couldn't use it as a display screen. We could have fixed this by using a VSN or running a remote computer from the Raspberry Pi, but we ultimately just decided to buy a tablet that was compatible with our Raspberry Pi. Here you can see a GUI flowchart. You start from the beginning of the program. From there, you pick a tab. You can see our cart tab at the top with all of its options available. When you finish with your cart, you can scan your membership card. If you have enough funds, the payment will be processed. If not, you'll see an insufficient funds sign. From the accounts tab, you can check your balance. And from the admin tab, you can add an account, update your balance, or remove an account. This is a video of our GUI interface. You can see our cart page here. The 5 buttons: add, remove, complete transaction, clear cart, and scan coupon. This is our accounts tab where you can see our 2 accounts and show balance at the bottom. You select an account and then you press show balance and it shows the user's balance. This is our admin account. Here you can add a new account, remove account, or update your balance. It's protected by a password so that users aren't able to go in and manipulate the database. Here's a demonstration of our cart tab. You can see here we're scanning cheese. We added 5 cheeses. And now we're showing the remove option. Ready to pay, you hit complete. You scan your payment card. Since he had enough money, his payment went through and his receipt got printed. Here's another demonstration using the barcode scanner. We're going to add an item to our cart. Once you added all of your items, you can scan a barcode. She's going to do that in a second. Here you can see her grabbing the scanner, scanning a coupon, and the coupon shows on your cart and your total's reflected. You're ready to pay, you hit complete checkout, scan your card, and you're good to go.
Here we have our admin and account tab. So in our account tab, we'll see the 2 accounts, and then we can see the balances of the 2 accounts. So Johnny Appleseed has 0 balance. And then if we go to admin, you can type in a user password that you can go in and change this balance. So we're gonna go in and change Johnny Appleseed's balance to $10. And then when we do this, we'll go back to verify that the changes were made in accounts. So then we'll show balance. And then you'll see that he now has $10 on his account. We also have a feature to show new accounts, to add accounts, and remove accounts. So we added in Johnny Appleseed and we gave him an initial deposit. And then once you hit OK, then we can tag it to what essentially would be a card, but since we don't have those, we use the tag to show that. And so now that is Johnny Appleseed's essential card. And then here is the kind of back end showing the SQL database. So here you will see the information where that's being stored, like shown previously of the accounts and the name, balance, and RFIDs associated with them. Similar to how the barcode scanner works, having the strings attached to the same barcode. And then the same way with the catalog. So it's some sense of automation here. So we don't have to type in these long numbers one by one. They'll automatically get scanned in and queried from that database. And the same thing with the receipt tab. Once the user indicates what items they want to use to scan in, those items are now stored to the receipt tab or removed from the receipt tab, depending on if they wanted to clear the card or not. And once they're ready for payment, then that will print out on the receipt.
So I'm gonna go over some of the bigger problems that we had. The first one was it was really hard to get Python 3.11 and the RFID libraries to connect. One time we incorrectly measured the 3D printed parts, requiring us to reprint them. And another big problem we had was trying just to get the GUI to display on the Raspberry Pi display. You can go to the next slide. And finally, some of the things we can try to aim to do in the future is, for example, try to install Bluetooth compatibility. This way we'll be able to expand out to add more features to the Smart Mart. And finally, using zero proof knowledge to prove the customers who they say they are, the user, so when they input